Okay, so let's start about this topic, second order ODE. So before we start, so this is roughly about our syllabus. So these are the flow for the study. So we have two parts. We're going to solve the first. We're going to solve the linear equation, the homogeneous. And the next, we're going to solve for the non-homogeneous second order ODEs. So for based on this one, to solving the non-homogeneous ODE. So we have two methods. First is the undeterminate coefficient, and second is the direction of parameters. So basically, we are going to cover each of them. Alright, first of all, we're talking about some detail. What is the linear second order ODE? So this is the first question to asking yourself. So what are the second order ODE will be? So first of all, based on our understanding, so the second order ODE, the highest derivative must be 2. So these are the general form of the second order ODE. So whereby each of the coefficient in front of the derivative here, and this one, and also this one must be in the function of x. So as long as this is in the function of x, all this thing is in the function of x, then we say this is the second order ODE. And this is what the higher derivative is just 2. So with this, then we say this is the second order ODE. So yes, and we say this is the second order ODE. So let's say we try to take the example here. So let's say this is the general form, and we take this example. So we have the derivative, we have first order, second order, and then the coefficient. Maybe you can put something like the function x or sine x, and also sine exponent x. And the last one we can just put in as another function of x. But for this subject purpose, we have treat all the a1, a2 are be the constant. So which means all are like something like the a, b, c for that. So next, so in order to know this is homogeneous or non-homogeneous, it's very easy. So when your fx is equal to 0, then we say this is a homogeneous equations. And let's say your fx is not equal to 0, that means this is not the homogeneous equation. That's why we can just separate in the two parts here. So the first one is a homogeneous, meaning that this is your fx is equal to 0, and the next one, your fx is not equal to 0. That's why it's here. So these are the example. You look at this one, your fx is equal to 0. That's why this is called homogeneous equation. But how about this one? The next, you see your fx is not equal to 0. That means this is a non-homogeneous second order differential equation. And for the next tutorial, we are going to solve the second order ODE with the homogeneous equation. So I think that's all. Thank you.